Right. Thank you so much for coming or viewing my talk. Before continuing, I would like to acknowledge the other authors of this work, Carly, John Michael, David, and Don Ye. We know that many systems live in these dynamics of disturbance and recovery. And we also know that climate change is going to make understanding disturbance a priority because we're expecting these disturbances in many places to be of higher magnitude. There's also high uncertainty. We know very little about how ecosystems are going to respond to these changes in disturbance regimes. But we also know that many systems are resilient. Many systems can go back to a previous dynamic equilibrium relatively quickly. And there's evidence from the paleontological record, and there's also evidence from current literature. I've been studying the dynamics of lizard malaria in Puerto Rico since we started in 2014. And in 2017, Hurricane Maria, which is a very, very strong hurricane four, passed through Puerto Rico. So, like many other studies, my study became a hurricane study. We wanted to understand now what are the consequences of this huge disturbance on different traits of the anoles living in this community. And here we're particularly interested in three aspects: phenotypic characteristics, changes in phenotypic characteristics, changes in demographic rates, and shifts in habitat use. In terms of phenotypic traits, the first trait that we looked was limb size. There was an interesting paper by Donahue in 2018 that following anoles in the same hurricane, but in the island of Turks and Caicos, and they found a really interesting pattern in which the lizards right after the hurricane had bigger limbs with respect to their body size. Here, this is data from our place in Luquillo. These are predictions from a gamma model. And at the beginning, right after the hurricane, we found the same thing. Right after the hurricane, the front limbs and the back limbs with respect to the SVL were big, and that ratio was bigger. However, after the hurricane, after 2 years, 2 years and a half after the hurricane, it seems that those rates are recovering in all species. So this might suggest that there's selection right after the hurricane, but not necessarily evolution. We also look at body condition, and this is a very, very interesting measure. This is a body condition index, which means that those individuals that have positive values mean that those individuals are fatter than what you expect on average. Those that have negative values are less or more skinnier than what you expect on average. And what we show here, right after the hurricane, individuals have relatively better body condition, particularly for anolis gunlaki, which is a strong ground anole. So why is that? Why anoles right after the hurricanes have better body condition? One potential explanation for that is an increase in insect abundance. We see that for a couple of different groups, right after the hurricane here in 2018, there was a huge increase in insect abundance, particularly for this group, which includes the ants, which are the rice and beans for these lizards. Um, we're also looking at changes in density. This is a work in progress. We're also looking at mark recapture data, but a broad view at catch per unit effort shows little changes in Anolis evermani and Anolis stratolus, but for Anolis gunlaki, which is the trunk ground anole, we have an important decrease in density right after the hurricane. We also see changes in habitat use. This is the DBH of the trees or the substrates in which we find the lizards. And right after the hurricane, the DBH of these trees increases. Right, the size of the trees that the lizards are using becomes bigger, and this makes sense because the hurricane, it was splitting and breaking those smaller branches, those smaller trees, and the ones standing were the bigger trees. So basically, the lizards are using the habitat that is left. But what is interesting is the model, and again, this is also the results of a gamma model. They also predict that that the size of the trees that they're using sort of starts recovering right after 2 years, 2 years and a half after the hurricane. So, is there evidence of density independent growth? The hurricane disturbance create the conditions for density independence growth following the disturbance. Maybe we have a general decrease in density. We have an increase in insect abundance, and a potential result of this increase in insect abundance or increase in resources is an increase in body condition. So thank you so much for coming here, and thank you for all the people that have provided us feedback and funding for this work. You can follow me on Twitter or send me an email. Thank you so much.